Okay, today is a part 3 of a transport layer. Outline. Introduction, transport layer protocol, user datagram protocol, transmission control protocol. Okay. User datagram protocol (UDP). The user datagram protocol is a connectionless, unreliable transport protocol. It does not add anything to the service of IP except for providing process-to-process instead of host-to-host communication. UDP is a very simple protocol, uses a minimum of overhead. The sending a small message and not caring much about reliable. UDP packets. UDP packets called user datagrams have a fixed size header of 8 bytes made of 4 fields, each of 2 bytes. Figure 9.39 shows the format of a user datagram. The first 2 fields define the source and destination post number. The third field defines the total length of the user datagram. Header plus data. The 16 bits can define a total length of 0 to 65,535 bytes. User datagram packet. Okay, the following is the content of a UDP header in a hexadecimal format. Is a question, and it is solution. UDP service. Earlier we discussed the general service provided by the transport layer protocol. In this section we discussed was portion of those general services provided by UDP. Process-to-process communication, communication-less connection service, flow control, error control. Okay. Connect, continued, checksum. Optional inclusion of checksum. Progression control, encapsulation and decapsulation. Queuing, multiplexing and demultiplexing. Comparisons, UDP and simple protocol. This is a postal header for checksum calculation. Okay, although UDP meets almost none of the criteria we mentioned earlier for reliable transport layer protocol. UDP is preferable for some applications. The reason is that some services may have some side effects that are either unacceptable or not preferable, and application designer sometimes needs to compromise to get the optimum. In this section, we first discuss some features of UDP that may need to be considered when the design application program and show typical application. UDP feature. Uh, Connectionless service, lack of other control, lack of congestion control. Typical application. A client-server application such as DNS use the service of UDP because a client needs to send a charge required to the server and to receive quick response from it. The response and request and response can each fit in one user datagram. Since only one message is exchanged in each direction, the connectionless feature is not an issue. The client or server does not worry that messages are delivered out of order. A client-server application such as SMTP, which is used in email, electronic mail, cannot use the service of a UDP because the user can send a long email message, which many include multimedia, uh, such as image, audio, or video. If the application uses UDP and the message does not fit in one single user datagram, or the message must be split by the application into different user datagrams. Uh, here Here the connectionless service may create problems. The user datagram may arrive and be delivered to the receiver application out of order. The receiver application may not be able to reorder the pieces. This means a connection service have a disadvantage for an application to send large messages. As soon we are downloading a very large text file from the internet, so we define it to use a transport layer that provides a real service. We don't want part of the file to be the missing or the corrupt. When I open the file, the delay created between the deliveries of the parts is not an overriding concern for us. We wait until the whole file is composed before looking at it. In this case, UDP is not a suitable transport layer. Assume we are using a real-time interact applications such as Skype. Audio and video are divided to frame and sent one after another. If the transport layer is supposed to resend a correct or loose frame, the synchronizing of the whole transmission may be lost, or the viewer suddenly sees a blank screen and need to undo the second transmission right. This is not tolerable. However, if a small part of a screen is sent using one single user datagram, the receiver UDP can easily ignore the corrupt or loose packet and deliver the rest of the application program that a part of the screen is blank for any short period of the most viewers don't even notice. Transmission control protocol. Protocol. Transmission control protocol. TCP is a connection-oriented, reliable protocol. TCP specifically defined connection is establishment, data transfer, and connection teardown phase to provide connect-oriented service. TCP uses a combine of a GBN, Gold Backend, and SR Selective Repeat Protocol to provide a reliability. Before discussing TCP in detail, let us expand the service offered by TCP to the process at the application layer. Process-set communication, stream delivery service, sending and receiving buffer segments, full duplex combination, multiplexing and demultiplexing, connection-oriented service, and reliable service. Okay, this is Steve delivery. A TCP feature to provide the service mentioned uh, in the previous section. TCP have several features that are briefly summarized in this section. Discussed later in the detail. Number system. So TCP connection is transferring a file or 5,000 bytes. The first byte is number 10,001. What are the sequence number for each segment? If the data are sent in the 5 segment, each carry 1,000 bytes. Search and follow show the sequence number for each segment. Before discuss TCP is more detail, let's discuss in TCP packets themselves. A packet in TCP is called segment. Format and encapsulation. TCP segment format. Control field. Pseudo header added to TCP datagram. Okay, next, TCP connection. TCP is a connection oriented. This discussed before a connection oriented transport protocol. It establishes a logical path between the source and destination of the segment belonging to a message are then sent over the logical path using a single logical pathway. For the entire message, facilitates the acknowledgement process as well as retransmissions of damaged or loose frame. Connection establishment, three-way handshaking, sync-floating attack, data transfer, pushing data, nutrient data, connection termination, three-way handshaking, half course, connection reset. Connection is must use a three-way handshaking. Data transfer. Connection termination using three-way handshaking. Half course. Half course. State transmission diagram to keep the track of the different events happening during connection establishment, connection termination, and data transfer. TCP specific as the infinite state machine FSM as shown in the figure. Scenario half course. Window in TCP uses two windows, send the window and receive the window for each direction of the data transfer, which means for the window for the bidirectional communication. To make a discussion simple, we make it unrealistic and unidirectional. The bidirectional communication can be inferred using a tool unidirectional communication with a piggybacking. Send window, receive window. Okay, send window in TCP. Receive window in TCP. Flow control, as discussed before, flow control balance the rate of producer create the data with the rate as consumer can use data. TCP separate the flow control from error control. In this section, we discuss the flow control, ignoring the error control. We assume that a logical channel and between the sending and receive TCP is error-free. Opening and closing window. A scenario, shrinking of the window or window shutdown, a silly window syndrome. a syndrome created by the sender, and a syndrome created by the receiver. Data flow and flow control, the feedback in TCP. Example of the flow control. Error control. It is TCP a reliable transport layer protocol. This is the mean that the application protocol that will deliver a stream of data to TCP will rely on the TCP delivered that entire stream to application protocol and in order without error and without any path loss or duplicated. According to checks of acknowledgement, ACK and SAC, generating acknowledgement, retransmission, RTO, and three duplicates of all for the segment. Let's continue. FSMS for data transfer in TCP. Sender slide SFM, receiver slide SSM. Some scenario. Normal operation, lost segment, fast retransmission, delay segment, duplicate segment, automatically corrected loss correction by reset segment, deadlock created by loss acknowledgement. Normal operation. When I send a data segment to the end bit, I have a two rule. In the picture, loss segment, fast retransmission, loss acknowledgement. Loss acknowledgement created by resetting a segment. TCP congestion control. TCP use different policy to handle the congestion in the network. We discussed this policy in this section. Congestion window, congestion detection, congestion policy. Slow, smart, and congestion avoidance. Policy transmission. Tahoe TCP, Reno TCP, and New Reno TCP. Additive increase, multiplicative decrease. TCP to push. Slow start, exponential increase. Congestion avoidance, additive increase. A summary. UDP is a UDP is a transport protocol that creates a process-to-process communication. TCP is a mostly unreliable and correlationless protocol that requires little overhead and offers fast delivery. The UDP packet is called a user datagram. Transmission control protocol (TCP) is another transport layer protocol in the TCP/IP protocol suite. The TCP supports process-to-process, through-packet, and connect-oriented service. The unit of data transfer between the two devices used to using TCP software called segment. A TCP connection consists of three phases: connection establishment, data transmission, connection terminates. TCP software is normally introduced as a finite state machine (FSM). Okay, finish this part. Say thank you everyone. ขอบคุณครับ